Welcome to Brain Vision.
We begin this question by calculating the mass of each of these parts. So we know that the weight force is given by W is equals to the mass times the gravity, in this case on Earth. And we know that the gravity on Earth is equals to 9.8 meters per second squared. Then the weight force is equal to the mass times 9.8 meters per second squared. Now we can solve for the mass by sending this 9.8 to the other side to get that the mass is equals to the weight divided by 9.8. Then we use this equation to calculate the weight of both parts of this probe, number 1 and number 2. For the part number 1, we have m1 is equals to the weight number 1, which is 1130 newtons, divided by 9.8. Now, for the other part, we have a mass m2 that is equals to 3400 divided by 9.8. Now, we have both masses, m1 and m2. The next thing we have to do is calculate what is the gravitational attraction between both of these parts. How can we do that? By remembering that the gravitational force is equals to Newton's constant times the mass number 1 times the mass number 2 divided by the distance between the centers of each of these masses squared. Then, by using the values that the problem gives us, we have that the gravitational force is equals to G times the mass number 1, which is 11,000 divided by 9.8, times 3400 divided by 9.8, and this whole thing is divided by r squared. For this question, r squared is this 12 meters, which is the distance between the centers of both parts. Then 12 squared. Now remember that the value of Newton's constant is equals to 6.67 times 10 to minus 11 newtons times meters squared divided by kilograms squared. Then the gravitational force is equals to 6.67 times 10 to minus 11 times 11,000 times 3400 divided by 12 squared times 9.8 squared. And this gives us a gravitational force of approximately 1.8 times 10 to minus 7 newtons.